All right, this is just some typical morning snow here in Colorado. You can see it glittering, I hope, in the camera. I hope the camera even does it, the snow justice here. It's a heavy snow. It's coarse, right? It's heavy powder, but it is certainly, without a doubt, powder. Now, as you probably can't see in this early morning light how bright and how reflective snow is. Now, on these peaks out here, it's just brilliant bright white. Now, remember, the sun has just risen, and it is already, of course, just shining how bright these peaks are. Now, the reflective property of snow and ice is called albedo, and albedo is super important. You can't lose albedo, and let me explain. So that reflective property of snow and ice essentially maintains itself. It is self-propagating, not propagating, but self-maintaining in that way. It reflects the solar energy that would be melting the ice. Okay, now let's say you lose albedo. Let's say for whatever reason there wasn't snow and ice, right? Which we know can happen. Wow, look at that. Isn't that incredible? So we know that there can be a loss of snow and ice in a habitat. If that happens, let's say it's a terrestrial habitat, land habitat. When you lose the albedo or snow and ice cover, and the sunlight is able to hit dark, rich, unreflective earth, that completely changes the soil temperature, which completely changes what seeds are able to germinate, when they germinate, all sorts of things. How much water is flowing, right? If all the snow melts at once, you get flash floods, you get landslides, right? Imagine if all that was matte black and all that snow that falls didn't stay there. It melted immediately. The flash floods and landslides would be incredible and incredibly dangerous, right? So that albedo is super important. Also, like melting snow cover is, integral to these habitats. You have to have these cold periods. You have to have the snow coverage. You have to have frost nights. That's really important in trees. When they flower and when they make seeds, is frost nights. The amount of nights below freezing. And so I'm trying to talk in this high altitude. There's not a lot of air up here. I'm well over 10,000 feet up here. So, and coming from 400 feet without like some time to acclimate then, and trying to talk and everything's kind of... Anyway, when you lose albedo in the Arctic, floating ice, the sea absorbs huge amounts of solar radiation. And you've probably seen on Planet Earth and other documentaries, when between the icebergs and everything, then the sea is black. The sea is deep and dark, and it absorbs that solar radiation, and that changes everything in the habitat. Even the speed at which things happen, even the metabolism of the animals in the water changes if that albedo is lost and the water starts to warm up. Now, the other thing in the Arctic is, and this is true of soil temperature as well, here in the Rocky Mountains, if the albedo is lost and the soil heats up, the next time it snows, the snow won't stick. It'll melt and you'll have flash floods and landslides and a permanent change in habitat because the snow won't stick. Now, in the Arctic, the same thing is true. If the sea warms up, then even if it was to get cold again, then the icebergs and ice sheets wouldn't form because the water is too warm, right? So the reflective property of snow and ice and the coverage of snow and ice is extremely important to these habitats. And that's why there's such a big deal being made over the rate at which the Earth is warming.